Okay, Anthony, you can start.
So good afternoon, everybody, and welcome to another online technology meeting at EPIC. This afternoon, we are going to talk about new mid-infrared developments for industrial manufacturing. We used to talk a lot about different parts of the spectra. We talk about how visible infrared laser, near-infrared lasers are used nowadays in the industry. We also talk about visible spectroscopy for different applications. But mid-infrared is really interesting to bring more information about some hidden components or components that are not very good detected in other parts of the spectra. It's also interesting wavelength for processing materials. So we are going to have a nice set of presentations today to talk about all these new developments that cover potential interesting applications about infrared sources and detectors. And as I mentioned, it's a technology meeting of EPIC. So for those of you who doesn't know what EPIC is, this is EPIC. It's a consortium of more than 800 corporate members. All of them are companies and research centers related with photonics. And the goal of EPIC is to ensure the sustainability of the photonics business in Europe, helping all our members to make new contacts, to find new partners and new collaborations. In this slide, you can see all the members we have nowadays. If you are interested in knowing a little bit of your benefits, you can contact me later on to discuss more in detail. But this is a short summary of what we offer to our members. So we have give access to different market reports to give information to our members that are interested in joining certain new market for them or exploring what's going to be the future. Also, we offer different access to markets and possibility of contact with mentors. We help them with human resources needs and also with investments for those big companies that are interested in contacting spin-off startups, and the other way around, small companies that want to be reached by investors. And also with the technology requests. So if somebody is interested in finding an alternative provider, is looking for somebody interested in the products, we help to with these technology contacts. And of course, with networking, like this online meeting. This is one of the main activities that we do. We organize activities all over the year to help our members to find new contacts, to allow them to interact with all companies from the whole supply chain in different topics. So we cover optics and micro-optics, spectroscopy, laser processing, space, and defense. Any topic that can be interesting for photonics, we organize meetings that allows you to interact and to find right contacts to develop your products, to find customers, or to find new suppliers for you. This is a summary of these networking events that we will have in the future. Next week, for example, we will have a quite interesting meeting in photonics assisted cancer pathology and surgery. It's going to be in the University Hospital of Antwerp, and we will have several medical doctors speaking about their work there. Also, some researchers talking about what they do in cancer pathology, and of course, companies with the last developments. So if you are interested in this topic, medical applications, it's a good opportunity to join a very interesting environment in a hospital. We'll have people from Antwerp, but from other European centers as well. So it's a nice opportunity to talk about medical related topics. And of course, we will be in the W3 fair as well, that we have a couple of activities, the EPIC Tech to Watch and the EPIC VIP breakfast. Also, we will be an Optro with a round table, and Photonics West is also on the corner ready. So we will start with all the activities that we normally do in San Francisco. Just put the first ones here in the slide, but I encourage you to go to our website so you can check all the opportunities to interact with people that we will offer during the show. And of course, online meetings, we will continue this the work that we started this year, not focused only in technology, also work groups like the Sustainable Photonics one, also a meeting about international delegations. So Carlos will show you what is expected for 2024, online marketing meeting as well, that they are more and more popular because we see an interesting need from our members in having support in marketing activities. And of course, another online technology meetings, one in food and beverage, that is probably also interesting for several of you. So I encourage you also to register there. And the first one in 2024 is going to be about graphene technology and applications. So again, in the bottom of this slide, you have the address of our website. I encourage you to visit and register in any of the events that is interesting for you. We are also working different European Union projects in the dissemination and communication activities. These are the ones that are active nowadays. JEPICS about photonic integrated circuits. MEDFAB is a pilot line for development, helping companies to develop medical devices based on photonic technologies. Multiple is a project to develop multimodal monitoring solutions. Fabulous focusing freeform micro optics. Also PhotoHub Europe as a support for any photonic application, and then Pulsate focusing laser-based advanced and additive manufacturing. And all these events that we organize are nothing without our sponsors. So I would like to thank the support of all the members that support our events, in this particular case, Actar and Advanced Coatings Materials, Art Photonics and Vortex. So I see Alexander here. Thank you very much for being here today, and perhaps you can say a few words about ACM coatings and what do you do.
Thank you, Antonio. My name is Alexander Telle. I am leading Actar's German subsidiary. Actar is an Israel-based technology company, and we focus on ultra black coatings for optic and photonic applications. You need them to suppress scattered light and stray light in optical systems, to absorb laser power, or to create high emissivity. And especially applications in the infrared, in this case in the MidIR range, are very attractive to us, as our coatings work very well as an absorber in that range. So you can use our coatings to suppress scattered light and stray light to enhance signal to noise ratio or image quality in this infrared range using our black coatings. But you can also use them to calibrate your system or to have high emissivity surfaces if you want to go deeper into the infrared, into thermal infrared applications.
Thank you very much, Alexander. And also thank you to our next sponsor, Art Photonics. And we also have here Alexander. So Alexander, the room is yours to explain a little bit about Art Photonics. What are you doing?
So hello everyone, Art Photonics GmbH is proud to be a sponsor for this epic webinar. Art Photonics is a global leader in mid-infrared fiber optics, providing cables for infrared lasers and fiber optic probes for industrial process control in extremely wide range, from 3 to 17 microns. Our workhorses for the mid-infrared range are flexible halcogenide and silver halide fibers, as well as hollow waveguides with broad transmission range. Our flexible polycrystalline silver halide fibers and hollow waveguides are perfect for applications with industrial high-power CO and CO2 lasers. And with our unique smart technology, we suppress Fresnel reflection losses to get maximum possible transmission of the laser power. In addition to that, we can build fiber bundles to combine light through serial quantum cascade lasers or other infrared light sources that was implemented during our European projects. Our various fiber probes can be used for all 4 key spectroscopy methods for remote process control in line: Raman spectroscopy, mid-infrared and near-infrared spectroscopy, and fluorescence. Moreover, our special probes are designed to be used in harsh environments with temperatures from -150 to +250 degrees of Celsius, high pressures like 200 bars or vacuum, vibrations, aggressive liquids or gases, electromagnetic fields including microwave and hard radiation. We offer to all our industrial end users to test all 4 spectroscopy methods and select the best one or their combination to fulfill their requirements. And don't forget that all end users can easily modify their bench spectrometers to the process spectrometers using our fiber couplers in sample chambers. Join the forefront of industrial spectroscopy innovation. Contact us today to explore how our solutions can enhance your process control and analytical capabilities. Thank you for your attention. If you have any questions, feel free to reach out me or use contact at our website.
Thank you very much, Alexander. And finally, also thank you to our sponsor, Vortex. Ian is going to have a presentation later on today, so he will have the chance to introduce you to the company Vortex as well. And let's go with the supply chain for today. This is the companies that are registering our events. So I see a nice, as always, combination of components manufacturers, people doing integration and being end users of these technologies, metrology and testing and R&D. We will upload this slide as always in the website of this event, so you can check later on all the people that are interested in this kind of technologies and register for the event. And let's go with the agenda for today. So we will start with Cristina Bertoni, is project leader in Electrolux, and we will proceed then with the presentations of Nippon Electric Gas, MUT, Mapsi, Verre, Fluore, Femtum, and we will finish with Vortex optical coatings. So I will start sharing the Cristina's presentation. It's not working in her computer, sorry. So let me check Cristina. Okay, so you can start the presentation and let me know when I should move slides.
Okay, thank you, Antonio. Thank you for inviting me today to update you about, as much as I can, about activities where Photonics is involved in our efforts to bring forward innovation in a consumer-centric approach. So if you move to the next slide, just a short introduction to Electrolux is more than 100 years company, started in 1919 with this Swedish entrepreneur, Axel Wenner-Gren, who established Electrolux in Sweden by producing and selling vacuum cleaners. Then the company grew by embracing also production of refrigerators and washing machines. And then if you move to the next slide, Antonio, the largest growth of the company was related to the acquisitions of major brands like Zanussi, Frigidaire, Westinghouse, and AEG, which are renowned brands I'm sure you heard about. Nowadays, if you move to the next slide, there are three main brands with the Electrolux brand covering 35% of sales, and is the brand under which we introduce to the market our premium and innovative products. Our product lines are divided in taste, so anything related to kitchen and food, care, so washing, dishwashing, and well-being, that is mostly related to air purifiers, air treatment systems inside the house, indoor air quality, and vacuum cleaners again, as at the beginning of this history. Then if you move to the next slide, at the moment, just to give you a next, please. Just to give you, let's say, a snapshot of where we sell our products and where is our largest footprint is in North America and Europe, and then also in Latin America, in Brazil. Most of our sales are in products for taste, so food preservation, food preparation, but then also in care, washing machine, dishwashing, and well-being accounts for 7% of our sales. Next slide, please, Antonio. So we really try to keep up with sustainability, as this is one of the requests that is given by consumers. There are as many as 63% of consumers willing to pay up to 15% more for a better experience in terms of sustainability. And as much as 93% of consumers wish to lead a more sustainable lifestyle. So we are really investing a lot in giving sustainability to our products and make the consumer happier and appreciating our products. Next slide. As a matter of fact, Electrolux has received several awards in sustainability, and it is actually it is included in the Dow Jones Sustainability World Index. Then if you move to the next slide, Electrolux has also set some science-based climate targets aligned with the 2015 Paris Climate Agreement to keep global temperature rise below 1.5 degrees C. We have as a target by 2025 to go to minus 80% of CO2 in terms of operations, and minus 25% of CO2 in terms of product use, where product use accounts for 85% of the CO2 climate impact of an appliance. Therefore, product efficiency is where Electrolux can make really the greatest contribution to tackling climate change. Then we will pursue objectives related to operations by 2030 and by becoming basically climate neutral across the value chain by 2050. Okay, now you can move to the next slide. And so the panorama has changed dramatically after the pandemic, and regarding the home lifestyle, which is the focus of our activity, certainly the pandemic increased the time spent at home. For instance, here I show you some data related to traffic reduction in Italy, related to not only the pandemic, but then the years 2021 and 2022, where we had like 3 million people working smart from remote, and this led to quite a dramatic reduction in traffic. Which of course impacts also on CO2 emissions as well, but certainly people spend more time at home. And therefore, as sustainability in any case requires time, the consumers are more willing than in the past to adopt sustainable behaviors, sustainable oriented behaviors. And we can work on many indexes to make the consumer aware about its or her or his behaviors in terms of energy consumption, water consumption, thermal comfort at home, and by using data acquired in our machines and providing these indexes to the consumer. Next slide, please. Regarding water usage and consumption, Electrolux is actively working also by networking at international levels. For instance, here I report the snapshot of a white paper on circular water future by the 50-liter coalition that is a coalition Electrolux is belonging to as a co-founder as well. And just to explain you how water and why water is so important, of course, we all know that water is it is really precious for all of us, but we can really improve the usage of water by our appliances by having something enabling to monitor the detergent concentration and the water quality along our washing processes. For instance, I just mentioned here how water hardness is greatly affecting detergent efficiency, and therefore water softening is one approach that we are implementing in our appliances in order to enhance detergent efficiency. However, there is still a lot to do in monitoring water quality along our processes, and we can certainly improve further the use of water along washing and rinsing. Okay, if you move to the next slide. Here I report our, let's say, broadly speaking, our targets, because of course I cannot share sensitive information about wavelength range for water quality monitoring in our appliances related to, of course, washing. So here you can find the wavelength range, the sampling time related to how many spectra we need to average at the moment to have some meaningful information. Regarding materials, of course, we need to have something that is in line with our list of restricted materials and something that is suitable for water contact. And the working temperature in washing is typically between ambient temperature and 90 degrees C. We look actively for new solutions also in the mid-infrared, and for instance, I report here a device that is basically a mid-infrared single-mode waveguide for spectroscopy of solids and liquids, and it uses quantum cascade lasers, or in any case tunable infrared light sources, and is actually working in a transmission range that is matching with our specifications. Then, of course, we can discuss about real implementation of this in a home appliance, because of cost, because of the fact, for instance, that the cell is 10 microliters. But if we really are heading towards very difficult times in terms of water supply, we need to look into these cutting-edge technologies from our point of view, because we don't know if in the near future we will need to implement something so impressive, let's say, also in the home settings. So if you move to the next slide, please. Here is just to show, now we move to another sector of sustainability that is really important to us, that is food storage and consumption. It appears from analysis related to what consumers waste, that actually, for instance, fruits and vegetables accounts for 20% of food wasted, and we can we actively work to monitor technologies enabling us to monitor the freshness of food stored inside the refrigerator. If you move to the next one. Okay. One possibility, for instance, is to add a camera, just a camera. There are normal cameras, but then there are also time-of-flight cameras that enables to have a 3D picture of food inside, and we worked also on near spectroscopy in order to have a picture of freshness, let's say, of some food items inside the fridge. Then if you move to the next one. Another activity that we carried out in the recent past was carried out along a European funded project called MIRFAB, that some of you may know directly. And we characterized in our labs a mid-infrared module provided by one of the partners of the project. And certainly the technology proved to be really good at matching our specifications. It's certainly something that we would like to have in our appliances, but there is still a long way to go in terms of miniaturization and cost. for the device to be integrated in our appliances. Still, certainly that project, I must say, increased perception and awareness about potentialities of mid-infrared sensing in home appliances, at least in our in R&D, in Electrolux R&D. Okay, so this is all, to be honest, for my presentation for today. I hope that I touched some interesting topics for the community that is connected today to this event, and I just look forward for your questions. Thank you.
Thank you very much, Cristina. So as always, we have time for questions. So I will encourage you to raise your hand and make your question to Cristina. Samuel? Yeah, Samuel from Verre. Hello, Samuel, do you hear me?
Yes.
Okay, so you can proceed with your question.
Yes, hello.
Hello.
Yes, I've got a question about water monitoring. Why the wavelength range you mentioned, which is not the water absorption peak?
Exactly, because we don't want to detect water. We would like to see what is inside water.
Okay.
Okay.
Okay, that's clear.
Sorry.
Thank you.
Thank you for your question. It is quite important that this is, I mean, it's clear. Yeah.
Okay.
For water quality, when we speak about water quality, it means whatever is inside water. Yes.
Okay. I'm talking about the same application. Is it possible to extract some sampling, let's say, in a kind of sampling cell and perform the measurement, or is it not enough?
At the moment, this is what we are planning to do effectively, because there are a lot of challenges. Because in any case, we aim for inline detection, and of course, I mean, it is a sort of inline detection, but it is not probably real time, because you need to, let's say, let some water, or you have a sampling of your bath over the time, but you take your time to make measurements, because I think we need to prioritize accuracy more than real time. And certainly it is going to require a deviation of some water. So it is actually a sampling.
Yeah, thank you. We also have Sebastian from IFO.
Hello, thanks for the nice talk. So I just wondered, this last slide you show about this current solution you're using. Can you describe which technology it is? Just a bit more.
No, well, this was not the technology we used, but that we tested. It's again a quantum cascade laser coupled to a photoacoustic detection system.
Okay. And you said that the main limitation for using this in your appliance and so on was mainly the, let's say, the compactness and also the cost.
Yes, absolutely.
But in terms of selectivity or speed,
selectivity, speed, sensitivity, robustness against other interference, against humidity and whatever. I mean, just passed everything. Just okay. It was performing well.
Okay. So in terms of performance was fine, but then these other aspects that you mentioned about compactness and cost.
Yeah.
This is something you were aiming for.
Yeah.
Okay. Okay.
And we have another question from Richard.
Yeah. Hi. I'm a little puzzled by your choice of wavelength range, because in the mid-infrared, if you're looking at water, you're probably limited to a 50 micron path length or something in that area, which has big problems for sampling. If you went to longer wavelengths, not only would the components be more widely available and cheaper, but you could use, millimeter or even centimeter path lengths and get the same sort of sensitivity. So I'm just puzzled as to why you're looking in the mid-infrared, which is, a difficult region to operate in general.
Yes, indeed. This is a request that we received by our, let's say, internal stakeholder related to washing, and therefore we need to look into mid-infrared. Certainly, we found some interesting solutions for laboratory testing right now. However, we looked also in near, for instance, commercial solutions for to see if we can see something useful already in that portion of the spectrum. I agree with you that the mid-infrared, and actually we told to our partners, internal, let's say, colleagues, that mid-infrared is quite challenging, but they studied this with university, and the results and the outcomes were astonishing, and that we can really detect really molecules that are in the washing bath, and that there is the wavelengths are belonging to that range. Then how this can be implemented, to be honest, is I'm here today to speak with you about this, and if any one of you has some inputs or feedback on this request, if you like, more than a solution, it's really a challenge that I share with you. You can also make comments emphasizing the criticism related to this approach, and I'm happy to hear also those.
Yeah, okay. Yeah, I just think that operating in the near infrared would be much easier. You'd have a problem with inorganics if you're looking for things like phosphates and stuff like that. But for organics, it's just going to be much easier operating in the near infrared. But anyway, thank you.
Welcome.
Thank you, Richard. And thank you very much, Cristina, for your nice presentation and also for challenging all the people. And as Cristina mentioned, feel free to contact us or her directly if you want to propose something or discuss your approach. So thank you again, Cristina.
Thanks to you, Antonio.
And we will move to our next speaker. So we have Mr. Yoshimasa Matsushita, Senior Engineer at Nippon Electric Gas. Thank you for being here so late for you, because he's speaking from Kyoto in Japan. And he's going to present their solutions in infrared optics made out of the characteristic glass of Nippon Electric Glass. So the floor is yours, and feel free to share your screen.
Okay. Okay. Can you see my slide?
Yeah, and we see the pointer as well.
Okay, thank you for introduction. Hello, my name is Yoshimasa Matsushita, representing Nippon Electric Glass. We are working on developing unique chalcogenide glass materials and infrared optics. Today, I'm eager to introduce our innovative material and optical components. First, a few words about Nippon Electric Glass. We are a glass manufacturer based in Japan. While headquartered in Japan, we have business locations across East Asia, Europe, and North America. We specialize in unique glass materials and contribute to society through various glass products. Our product range includes 5 key sectors detailed on the right side of this slide. Because electronic product sector includes optical glass materials, we began development of optical materials for the infrared region. In recent times, infrared technology has garnered significant attention. Infrared light has been used in many applications, as shown here. In industrial manufacturing, it is used for gas sensing, temperature monitoring, laser processing. In every application, materials for optics play an important role. And because common optical glass materials cannot transmit IR light, specialized materials for IR optics are necessary for IR applications. There are some materials for IR optics, but there are few choices. This chart illustrates the market distribution of materials used for IR lenses. Germanium, chalcogenide glass, and silicon are widely used. However, they each has its strengths and challenges. While germanium has superior optical properties, it is not suitable for mass production. On the other hand, chalcogenide glasses can be press-formed and exhibit high productivity of optics, but their optical properties do not surpass germanium. In addition, many of them contain large amounts of highly toxic substances, like arsenic or selenium. Silicon is a low-cost material, but it is used only in low-end applications due to its absorption in IR range. Recognizing this, I'd like to propose our unique chalcogenide glass materials, named FI02, and optical components based on it as a new option. This graph depicts the internal transmittance spectra of IR transmitting materials. Essentially, the transmittance minus surface reflection. The term conventional chalcogenide glass means commercially available materials primarily composed of selenium. From this graph, you can see that both germanium and conventional chalcogenide glasses has absorption peaks beyond the 10 micrometer range. In contrast, FI02 has no absorption peaks and the highest transmittance within the sensitivity range of IR cameras. This excellent transmission property of the FI02 is expected to enhance the quality of IR images. In addition, FI02 is suitable for applications requiring transmission up to longer wavelengths. This table summarizes the properties of IR transmitting materials. Besides its excellent IR transmittance previously mentioned, high refractive index, availability of press molding, and not containing hazardous substances are advantages of FI02. Its high refractive index contributes to downsizing optics. Press molding enables optical elements with complex shape, such as aspherical lenses, to be fabricated with high productivity. Unlike conventional chalcogenide glasses, FI02 is free from highly toxic elements, like arsenic or selenium. In essence, FI02 is new chalcogenide glass that has unique properties. And FI02 is already in production and commercialized. As an example of optical components using FI02, I'd like to introduce lens for IR camera. In optical design, the advantage of the FI02 has been used to improve resolution This figure reveals the relationship between the center thickness of the second lens and the RMS radius of the spot diagram in our lens design. It has been established that a thicker second lens diminishes the radius of the spot diagram, thereby effectively curving aberrations. While thicker lenses are generally avoided due to declining transmittance, our lens unit's transmittance remains largely unaffected, even at the T varies from 2 to 9 millimeter, because of F502's high transmittance. This serves as a testament to F502's properties, enhancing the performance of the lens units. Here, we compare our FIR images with existing lens in the market that has the exact same focal length and F number as ours. Kindly observe the video comparison. You will notice an enhanced contrast between buildings and mountains. This could be attributed to F502's excellent transmission capability. Moreover, with our lens units, the electric cables around here are distinctly visible. This could be attributed to our high-resolution optical design previously mentioned. It is evident that our lens units enhance the quality of the FIR image even when the focal length and F number are identical. As conclusions, I'd like to summarize my presentation by answering the question, what can we do? We can enhance the quality of infrared devices by our unique chalcogenide material, F502. F502 glass blank is available, but we can offer optical components using F502 as well. In this presentation, I have introduced the lens for IR cameras as an example of optical component, but we also have experience in developing optical components using F502 in various fields, such as for spectroscopy, infrared lasers. We are looking forward to working with you to create innovative products using F502. Thank you for your kind attention.
Thank you very much, Mr. Matsushita. We already have a question from Ian from Vortex.
Hi, thank you very much for a really interesting presentation there. What my question is how does it compare with, say, germanium and say zinc selenide in terms of cost? Is it double the cost or triple the cost? Yeah.
It's it's very difficult to answer in this place, but it is the cost is
it comparable cost?
Yeah, comparable and more reasonable than germanium.
Yeah. Okay, that's fine. Comparables are a good answer. Thank you.
Thank you.
We also have a question in the chat from Dirk from Ideas. Do you want to make the question by yourself, Dirk? Well, if not, he's not available. You show internal transmission for the F802. Do you also offer
yes.
anti-reflective coatings? And what will be the typical total transmissions?
Yeah, we can for anti-reflective coatings. Yeah.
And the transmissions?
Yes. What would be typical transmissions? It depends on wavelength, so it's difficult to answer. But in 12 micrometer, the transmission is over 99%.
And we have another question from Rainer from Alexis. Rainer, do you want to make the question by yourself?
Glass formula. Glass formula. I can't answer about glass composition. Sorry.
Okay, good. So I think there is no more questions. So thank you very much for your nice presentation. And if anybody is interested in discussing more in detail, also feel free to contact us so we can also introduce to the Nippon Electric Gas team. So thank you, Mr. Matsushita, for being here today.
Thank you so much.
And we go back to spectroscopy. So we are going to talk about non-dispersive infrared by MUT group. So presentation will be by Carsten, Oldorf director, but I think Oliver, you are going to introduce first your company. So the floor is yours, MUT team.
Yes, thank you, Antonio. Welcome everybody to the presentation. We will talk about MidIR spectroscopy and the benefits if using that for multi-gas sensors. Before Carsten jumps into the topic, I will say a few words, only 2 slides about our company and group company. So you might not have heard about Nynomic yet, but I'm sure you know a few of the 12 sister companies that we have in the group. I guess everybody knows Avantis, who deliver spectroscopy solutions based on compact spectrometers, light sources, light guides, everything you need for spectroscopy. And then Tech5 is a company that is also quite widely known for spectroscopy solutions from the UV to the near infrared for process analytics. And I guess a few have heard also about Spectral Engines, who have a Fabry-Perot-based handheld spectrometer that runs on the cloud service and can identify all kinds of different substances, for example, drugs. And then we have as the latest member in our group, MidIR, a company from Denmark, who really has a great innovative technology, making mid-infrared spectroscopy much more accessible by using upconversion that allows then to use inexpensive silicon-based detectors to conduct MIR spectroscopy. I think that might also be a good fit for today, but I'm sure there will be other occasions where you can learn about that. Now to MUT. MUT is a company with more than 100 employees who has 3 different business areas. One is life science, where it's mostly about lab automation for handling blood samples for diagnostics. We have the green tech area, where we use mostly NIR spectroscopy to detect nutrient content, for example, in manure, or also in crops before and during harvest. And last not least, we have the industrial sensing business area, where we cover gas sensing, which is today's topic. We have fire detection and control for equipment to put out fire after detection, and we have an area dealing with sensors for transportation. That should do it as an introduction, and now Carsten will take over.
All right, we will go directly into the topic. We would talk about NDIR, optical gas measurement, which is a conventional kind of measure gases optically. What is special about us? First, I want to introduce a bit of the technology. NDIR is based on a broadband infrared emitter. The radiation is then passed through a gas cuvette onto optical detectors, which are covered by optical filters, which cut out a part of the spectrum. So every filter channel is usually dedicated to one gas that has to be detected. Shown here is a two channel setup. What is special about the MUT approach? We have here in this position a 9-channel setup, so we can make a multi-gas analyzer using this kind of technology. And to keep these analyzer small, we're also using a multi-reflection white cell, which folds the infrared beam as shown here on the right, and it elongates the pass through the gas to be measured to improve the absorption length and keep the whole module compact. Well, the basic principle, the physics of the functionality is the absorption following the Beer-Lambert law. And we are here in the mid-infrared range, starting from 2.5 microns up to 12 microns. And what you see here is the absorption spectra of various chemical compounds that we are able to measure. And as you see, there are a lot of absorption bands. So these bands, including water and many hydrocarbons, CO2, and many more, overlap a lot. So what can you do to improve selectivity? You can first choose filters that are in a way that the cross sensitivities are minimized. But if you have, like in our case, 7 or 8 different gases, that will not have the result that your signals will be free of cross sensitivities. So what else can you do? You can cut the residual cross sensitivities using algorithms. And how does this work? You're taking the raw data from your optical channels and put it into multivariate algorithms. And these multivariate algorithms have to be calibrated using various gas concentrations of the combinations you want to measure. So the algorithms then learn how the system behaves when different gases are present, and so you can basically eliminate all the cross sensitivities from your sensor. What you will do afterward, you can add on physical compensation algorithms like pressure or temperature, and then output it in a way you want to do. What you see here in the gray box, it's all included in the compact module that we are providing. And this is how it looks like. It's an OEM module that is custom made for special purpose. So the white cell is included, all the electronics and computers that makes the calculation of the algorithms. And it provides a measuring range from a single-digit ppm to % range, depending on the gases and the calibration. And the proprietary 9-channel detector enables it to measure up to 8 optical gases optically. And due to the optical principle, there is no chemical reaction in the gas sensor. And also compared to other methods like gas chromatography, no additional gases are needed to make the measurement. And also there are no moving parts, so it's designed for standalone long-term operation. We already qualified standard optical filters for various gases, as you see here, but also customizable optical filter options are possible to adapt here. What it is used for up to now, main application for these. No, sorry. I will show you. The other features of the cell we designed here. We can also add conventional sensors into the cell. This is an image of an explosion image of the sensor. So what is usually included is a temperature, pressure, and humidity sensor, which protrudes into the gas chamber here, and also can be equipped with hydrogen, oxygen, or custom chemical sensors for special gases. We have some additional sensors for ambient detection, and the interface is described down here. So what it is used for? Main application right now is dissolved gas analysis. So what is this? Oil is used for insulation and heat transfer in high power transformers, and the molecules of the oil and of other insulation materials may break up in smaller molecules due to transformer faults. And these gases are analyzed and can be used for condition-based maintenance. So depending on the type of fault, the fault can be derived from the gases or from the concentration ratio of the gases that can be extracted from the oil. This could be, for example, overheating or partial discharge or arcing within the transformer. So the provider of the transformer has a mean to see what kind of fault is developing within the transformer. And conventional dissolved gas analysis is usually done once or twice a year, taking samples of the oil and then bringing it to lab for analysis. And so our sensor enables the continuous online monitoring of these transformers. And this is an essential part of integrating transformers into smart grids to balance all the power necessary to move all the energy through the high power electrical grids. Down here, you find the gases we can analyze now, but we can actually analyze nearly every hydrocarbon or even organic chemical that is around. So Oliver, may you take over again?
Yes. Then the next slide, please. Yeah, so as we've been participating in EPIC meetings before, we know what questions to expect. So what can we do for you and your customers? We are an oil manufacturer, so we can develop your product ideas and bring them into serious production in very high quality. And based on our experience of almost 3 decades, we can integrate IR detectors with emitters and also other measurement principles to make your customized OEM sensor module. And we support you, of course, in the application and usage of the modules with our extensive knowledge of gas measurement technology. We only talked about gas measurement today, but we also use from our group and sister companies other spectroscopic technologies like UV to near-infrared visible technology to develop what you need. And yeah, next slide, please. And we are, of course, interested in hearing from you, what are your challenges? So if you have an idea for a product, we can be a development partner, and we can also manufacture then in high quantities. And if you don't have a really product yet to be developed, but an idea of what you need to measure, just let us know. Challenge us with your ideas for applications of especially multi-gas sensors. So I think that's it from our side.
Great. So thank you, Carsten and Oliver, for a nice presentation. And I saw that Oliver, you were busy already answering questions in the chat. But if Yang or Martin, you want to extend the discussion, feel free to raise your hands. Is there any other question for MUT? Yeah, Cristina.
Thank you. Is this system can be made more compact, like by reducing perhaps the number of gas targets?
In principle, it can be made more compact by different means, but not necessarily by fewer gases. So the principle stays the same, but it also depends on the concentration you want to measure, how compact it can become. Carsten has brought up the formula that defines more or less the dimension of the gas cell.
Well, the absorption of the gases it depends mainly on an gas-specific absorption coefficient, the concentration and the length of the absorption. This is what is in the Beer-Lambert law. So you need the length to get to low concentrations.
Yeah. Okay.
But contact us and sorry.
Sorry. At the moment, what is the range of concentrations that you can that you look for? I mean,
it depends on the gas and the kind of cross sensitivities, but for most gases we can get to single-digit ppm limit of detection ranges.
Okay. Thank you.
Thank you, Cristina. We have another question from Sebastian from IFO.
Yes, hello. Just for curiosity, which is the optical detector that you use in your MidIR system?
The detector, it's a thumb pulse detector.
Okay, and you have it, which is also the rise time typically for this, like the speed of detection of the gases.
This depends a bit on the sensitivity you want to measure. It's usually processed over wise. So you have a average over several seconds or up to minutes, depending on what kind of detection limit you want to reach. So this is basically a statistical function of the measurement speed. We could go to below seconds. It's a relatively slow detection method. So it usually the limit is around 1 second, or we can go up to 2 minutes to improve noise ratios and the limit of detection.
I see, because you also do kind of average of the spectrum, right? To reduce the noise, right?
I didn't got that.
Sorry, that you typically do spectrums to several spectrums to average and then to reduce the noise. Right?
Yeah, we do averaging over time to reduce noise, and so with a fast response, the noise will rise, and so the limit of detection also will rise up. So, but in principle, we could go below 1 second with a lower or with a higher limit of detection then.
Okay, thank you.
Perfect. So if there is no more questions, thank you again, Carsten and Oliver. Nice presentation. Yeah. And we can move to our next speaker. We continue talking about sensing, and we move to Mapsi Photonics. We have today David Cardador, he's founder and CEO of this company. So, David, the floor is yours. You can share your screen.
Hello, everybody. Thank you for the introduction. I guess you can see it correctly.
We see your slides.
So, okay. Thank you. So I am David. As Antonio said, I am the CEO of Mapsi Photonics and one of its founders. Mapsi Photonics, we are a 2-year-old company based in Barcelona, and we manufacture infrared filters that are used basically in thermal cameras and in gas sensors, and for industrial applications especially, but also, like, for example, industrial monitoring or gas leak detection. But also we address to some kind of medical applications such as thermography. The technology that we are using is completely disruptive and different from the one in the market. The one in the market now is multi-layer filters. We avoid totally these multi-layers of different materials. And what we are doing is just using a silicon wafer, and we perform we drill this silicon, and by controlling the shape of those holes, we are going to be able to, for example, to increase some capabilities of the current technology. For instance, if we go above 5 microns, 6 microns, we can increase the resolution of the current technology because our technology is really intrinsically good at these wavelengths. We go from 5, 6 until 25 microns, for example. Of course, we can produce a little bit lower, but in here, like in 4 microns, our characteristics are quite similar from the ones of the competence. But as we are using silicon, and we are all silicon platform, we are very resistant to harsh environments at high temperature environments, as well as high humidity environments. We don't feel the difference since the silicon melts at 1,200 degrees. We can suffer a lot of different high temperatures. And also, not only the technology is quite disruptive, but also the way that we will manufacture. Usually multi-layer filters, what they do is they manufacture in a chamber, and they produce several filters in parallel. We can also do this working in parallel, but we can address to some more specific needs from our customers that sometimes they need to develop small batches of filters, so we can adjust directly for the number of units that they require. Of course, this the price, it's also going to be increased than standardized filters, but the developing time as well as the developing design is quite less, and here we are also cheaper. And also the manufacturing process, in internal studies that we have done, we have seen that we can reduce more than 75% of the CO2 released, because we are not using exotic materials, and we are just using some really standard chemicals and very few of them. So we reduce also the CO2 that we deliver to the atmosphere. The benefits of our technology, I have already said that, but what our customers highlight are that we use thinner filters, that we can work in 200 microns, 300 microns, and this can be also interesting to integrate them inside gas sensors, for example. And so they simplify the design and reduce the solid angle variations, not only because we avoid multi-layer filters, so the layers, but also because they are thinner. We can manufacture at any shape, and we can cut our filters after being manufactured. We can go to and explore. Of course, they are explored, but I mean that some wavelengths that the competence has some difficulties to target. For example, in the 625 region, as I was saying, we are naturally manufacturing our filters and with really good optical characteristics. And as I said before, we adjust to we adjust to the customers' demands and the units that they require. One of the products that we didn't expect, as I said, we are a startup, 2 years old, and we were focusing mainly in narrowband pass filters. But as we went into the market, we saw that one of the products that are attractive to our customers are the windows that we manufacture. You can see here the 3 of the spectral response of these 3 different windows. In fact, the first one is from 1 to 5 microns, but it's also interesting, the 3 to 5 frame. And yeah, so we can also produce in the long infrared region 8 to 12, in fact 7 to 14, and the whole spectral range from 3 to 14. We are above 70%. Many times we are much above of 80%. And one of the things that is interesting for this is that, as I said, we don't use multi-layer filters, so we don't use anti-reflection layers, and we avoid the angle variation, which is something interesting also for our customers. And that since we use only silicone, our filters can be used really easily cleaned with alcohol, water, or wipes, for example. Other products that we have is neutral density filters that are used in thermal cameras just to reduce the amount of impinging light that it's impacting to the camera. We can manufacture, as I said, from 90 to 1% or 0.5% of transmission, really flat when we are in low transmissions. And also narrowband pass filters that are used in thermal cameras as well as in gas sensing. And this is really interesting, the ones of the narrowband pass filters that we have, because we have proven that when we have some coatings inside our filters, since we are porous, we can increase a lot the interaction, the light with the molecules that are inside the pores. And with solids, we have proven that we increase 1,000 times the sensitivity of the gas sensors that use our filters. And now we are testing. We still don't have really a good conclusion on that because it's more difficult than in solids. But they suggest these studies that we are also increasing quite a lot the sensitivity. And just stay tuned in our website because we are going to announce it in the next weeks, as well as other product lines that we are going to launch, and we are going to start the design. For example, selective thermal emitters, like using the same platform, the same technology as our filters, and we're going to develop them in 2024, finishing and marketing them in 2025. So as I told you before, just stay tuned in our website that is going to announce in the next week. Thank you very much.
Thank you very much, David. Great presentation. And we already have a question from Jorge.
Hello. Good afternoon.
Hello.
Thank you for your presentation, Jorge Sanchez,
Thank you.
for Kedri optical coating. Which is the maximum? I have a lot. We may have a lot of questions about your presentation, but okay, we should select 2. Which is the maximum diameter in terms of silicon wafer you can treat? For which type of applications? Because you talk filters, but filters, which one? High band, cross band, narrow one, which is the OD in terms of filtering?
Yeah.
And the homogeneity in the maximum capacity you may propose.
Yeah. Okay. Now we are manufacturing above 1 inch. Okay, with 4-inch wafers, but now we are moving to 6-inch wafers and with a manufacturing area of 2-inch wafer, 2 inches. Okay, we are moving from another to another place now, and we are increasing quite a lot our capabilities. And one of the focus and the main goals that we have is to increase the the attacking area, but I mean we are addressing 1 inch now, and then we are going to 2 inches filters quite in the few months. Respect the ODE, we are now in 2.5. We are not in 3 still, but we expect to be in the next months. And the homogeneity, there is not too much variation. The last test that we made the last week, it was around 1% or 2%, depending on the point that you are focusing. But it's quite standard, the homogeneity that we have. Of course, we want to increase this, but we are in the standards of the market.
And the reproducibility of this great figure of merit, no qualitatively, but which is the reproducibility?
Yeah, we can do it. We have a standardized process.
You have any figure of merit about this? Any graph to show?
Sorry?
You have any graph to show us?
Now?
Graph. Any graph? Comparison. Figure of merit. Any graph?
Yeah, I have them, but not now. I can send you if you want.
Thank you very much.
Thank you, Jorge. We can put you in contact with David so you can exchange some more information. Yeah, Cristina?
Hi, thank you for this presentation. And regarding gas sensing, what you showed is projections, or you have already, let's say, made some tests, developed some demo systems or something like that?
You meaning for higher sensitivity?
Yeah.
Using our filters? Yeah, what we have done some tests with solids, as I was telling you, inside our pores, and we have increased more than 1,000 the sensitivity, but just with solids. And now we are focusing in gas. We have just internal studies, and we want to externalize these studies just to be sure that we can increase also these levels in using gas and going the gases inside our filters. So what we have by now, it's just internal studies, and we want to externalize this.
Okay, thank you.
Any other question for David? If not, I will perhaps finish with the epic question. You mentioned, what can you do? Perhaps you can also tell us a little bit, what can the others do for Mapsi at this stage of the company?
It would be interesting, someone that has some sensing capabilities, just to check this, what I was saying, if the gas goes inside to our pores and it increases the sensitivity or not, because we are doing with our own capex, our own instrumentations, but it would be also interesting to someone that has some more capabilities than ours.
Yeah. So if anybody in the room is interested, please let us know, that we can introduce you also to David. So thank you so much for your nice presentation today. And we can move to our next speaker. So we're talking a lot about the spectroscopy, and of course we need fibers, and we are going to talk about fluoride glass fibers. So it's a pleasure to introduce Samuel Poulain, General Manager at Verre Fluore. So Samuel, the floor is yours.
Thank you. Can you hear me?
We hear you, and we see the presentation good. Yeah.
So, hello everybody. So I'm here to talk about the industrial uses of fluoride glass technology. First of all, what are we talking about? We are talking about where there is a transmission, very good transmission from 2 microns up to 5 microns. So we don't talk about 10 microns, 12 microns, just up to 5.5 microns. And fluoride glass is the best host for very low loss fibers in this 2-5 micron wavelength band. In addition, we can make a new generation of lasers because we can have a high concentration of rare earths, and the phonon energy of our glass is low. So there are many rare earth transitions that leads to many new fiber laser we are currently commercializing. So first, I want to talk about the past rather quickly. We've got an history for oil and gas spectroscopy with British Petroleum and then ABB that led to online spectroscopy system, and it is used now in tens of refineries. So the operating wavelength is from 1 microns to 2.4 microns, and just because of the 2 microns, 2.4 microns region, fluoride glass fiber is required. So what do we do at Verre Fluore? We supply multi-mode Z-bond fiber patch cables and the flow cell you can see in the picture that makes the interface between the liquid and the optical system. At Verre Fluore, we are component manufacturer. We are not integrators. So the integrator is a French company, Topnier System in France. And you can see a picture of a system using, so it's an online spectroscopy for oil and gas, a French refinery. Second application we developed 15 years ago with ArcelorMittal is wet paint thickness sensor for coil coating. So the main customer was ArcelorMittal. So it just reflection spectroscopy. But the interest of the technology is that you measure when the paint is wet, and it gives you the thickness once the paint is dry after curing. Because actually the spectroscopy absorption relies mainly on pigment, not on solvent. So once the solvent removes, the signal is the same. It's a patented solution. We've got typical precision at 1%, which is large enough for the needs of companies such as ArcelorMittal. It's an industrial use, so steel ribbon speed up to 3 meters per second. It's significant for coil coating industry. And it's in an explosive atmosphere environment. So the system has been certified 8x2. Actually, it's the only time where Le Verre Fluore supplied a complete system. We no longer commercialize this because we've got much better to do with our fibers. So as a conclusion, it's a relevant technology, approved, it works, but we no longer make business with this device. And if a company is interested in commercializing such device, we would be pleased to discuss. Now let's talk about the future. I will talk about 2 topics. First, gas sensing. So I explained that we are component manufacturer, mainly focused on fibers. So we have developed fiber solution for pigtailing and combining of laser diodes operating up to 6 microns. Beyond that, other technology are required. The main interest, of course, easy to integrate, no optical adjustment, which is critical for integrators. No free space length. The beam quality is better after the fiber than before the fiber. Currently, when we try to couple an ICL or QCL through a fiber, we've got from 30% to 50% transmission, which is from 50% to 70% losses. We have developed and integrated a solution where we have a breakthrough in terms of transmission. because we only have from 20 to 30% injection losses, which allows to improve significantly signal noise ratio, which is key when you make some measurements. So the application, industrial process monitoring and urban pollution monitoring. Once again, we are component manufacturers. We won't integrate, we won't buy QCL to integrate them into a complex system. We just supply the technical solution that optimize the coupling losses on the transmission. The latest slide is about some current studies, because with our fibers, we can make some fiber laser, and we've got a joint venture, a Canadian joint venture, Louis-Rafaël Lasers, that makes some fiber laser, just CW laser, currently mainly dedicated on medical application, but we can also make some plastic processing using this laser at 3.3 micron. Actually, when it's about plastic processing, everything is the devil is in the detail. Depending on the plastic, there are already some technical solutions which are relevant, because many plastics have an absorption peak around 12 microns. So a CO2 laser makes the job. However, there are some other plastics where there is no absorption peak at 12 microns. Alternative wavelength is required, for instance, 3.3, 3.4 microns, which corresponds to CH absorption peak. So more powerful versions are under development in Canada, but in parallel, there are some technical studies that are laid to qualify the solution for industrial uses, for very specific use cases, for specific plastic, in particular high density PE. So my conclusion, what can we do together? Industrial partnership to spread the technology. Actually, at Verre, we see more and more potential application, and we want to stay at our level, which is fiber or fiber subsystem, reliable subsystem, but we are not integrators. So we really want to make some partnerships to allow some companies to integrate our technology for a spectroscopy solution in particular. Thank you.
Thank you very much, Samuel. Any question? I have one question I remember from my previous years with FTIR solutions is the issue with the length of the fiber. I don't know what's the situation now with these fluoride fibers. Is there any option to go to longer fibers, or there is still a big limitation?
I don't understand what you're talking about. We know.
Yeah, I'm talking about the length of the fiber. How many meters?
Depending on the fiber, you need, for instance, for oil and gas spectroscopy, we are talking about two fiber patch cable, 100 meter long. For industrial case, yes, this is something we do. So no, we've got no particular issue in fiber length.
Okay. Yeah. So it moved faster, because I remember some several years ago, working with FTIR solutions, there was quite a limitation in the fibers to a couple of meters, 3 meters. So
I'm sorry, but not Fluore. No.
Okay.
No. Maybe others, but us, no. 20 years ago, we used to make very long fibers. So no.
Good.
This is something we do rather well.
Very good. Good to know.
Now, I insist on one point. In oil and gas spectroscopy and in wet paint thickness sensor, they are still used in an industrial environment. Several 20 years ago, and we did not sold any replacement device or components. They are still operating So we prove the reliability of our technology in industrial environment, in particular, explosive atmosphere.
Yeah, very good, very good. Any other question for Fluore? If not, thank you again for your nice presentation, Samuel, and also for showing these two future ideas, let's say, and also for talking about laser for fibers, because this is the next talk is about how this mid-infrared is moving also for laser processing of materials, and we have the presentation from Femtum. So Louis-Rafaël Robichaud is CEO and co-founder of Femtum. And he's going to present the solutions for processing of materials. So Louis-Rafaël, the floor is yours.
Thank you very much. Can you hear me well?
Yeah, we hear you and we see the presentation as well.
Great. Well, thank you very much, Samuel, and all the speakers before me to lay the ground about mid-infrared. So in a nutshell, what we do at Femtum, we really build the next generation of mid-infrared lasers for science and industry. We have developed a unique technology, a unique laser, which happens to be the world first. And there's a unique laser, and basically there's a combination of features here. So it's a short pulse from femtosecond to nanosecond pulses in the mid-infrared space. And these are fiber lasers. So you get the industrial grade robustness of a fiber laser technology. And Femtum, the real focus we have is really to assist our clients in their most demanding photonic applications. And to do that, we have also equipped ourselves with an in-house laser macro processing station. We have a 5-axis. We can, basically develop any types of processes in-house, and we have built a huge expertise on laser processing of, let's say, advanced materials. And I will go through it today during this talk. First disclaimer, I will just describe, let's say, commercial ready applications. So any upcoming very sexy things that we're developing, we're not going to discuss this. These are still under NDAs, but a lot of things are upcoming, and I'm very excited about such new developments. But first, let's talk about the 3 micron range. Basically, its importance is because you can really target strong molecular absorption bands. It has been covered already today. And here is a very simple plot of like the linear molecular absorptions in that spectrum range. And you can, because of this super strong absorption of water, of CH, and on many applications, you can target in the scientific space very advanced but very exciting new developments on the frequency comms, IR spectroscopy, IR imaging. And on the industry side, you can do polymer processing, you can do selective processings, and you can do also surgical procedures, which requires super high precisions. So right now in the market space, if you look at industrial grade, let's say pulsed lasers, what you will find is that the ytterbium fiber laser system is the dominant, it's a laser technology at 1 micron. It's a scalable, super robust technology, and it has been, let's say, driven mainly by IPG Photonics. You have, let's say, down-converted laser systems in the UV, in the green, that you can double or triple because, let's say, the frequency. There's a lot of excimer laser technology in the UV as well that are super interesting and, let's say, widely used in the semiconductor industry. And now when you try to go in the mid-infrared space, you have the thulium fiber laser, which is pretty, let's say, mature and very good. But in my point of view, the absorption bands of the molecules are not that high, and it lacks of a bit of the flexibility on the processing side. And you can find in the market space as well the CO2 laser, which is widely used, super cheap, highly powerful. But the CO2 laser is a very big spot size. You cannot do very small features on materials. And Femtum, we basically cover this gap in the 3 micron range, where we can really target, let's say, advanced materials or the molecular absorption band of the materials. So today I'll just describe the 2 most popular product lines we have at Femtum. So we have the UltraTune series, which is very unique laser, which is patented. And I'll go through the nanosecond platform just after. So it's a laser where you have a diffraction, a limited beam quality. So it's a perfect Gaussian beam, and it emits in a very, let's say, stable, easy way pulses at a very high repetition rates, at very high peak power, and in quite very good average power. And you can have very short pulses. So here is just, let's say, typical specs that we provide on this platform. And here you can really see the tailoring of the spectrum of this platform. What is really unique here is that normally let's say, the competitive technology is mainly for such broadband pulses, or let's say broadband light source. It's an OPA or an OPO, which needs to be, let's say, calibrated like by turning angles, and it's not really let's say, user friendly. In our case, this laser, you're basically just pressing a button on a software, and it's instantaneous. The tuning, it's super fast, it's super accurate. You basically open the laser, and there's almost no warm up time. So within 10 seconds, you're starting to have a laser, and you don't need to do fancy stuff to make the laser let's say work in the lab. So you can really focus on your application in the field. And most of the applications for this platform is about advanced spectroscopy. So let's say the upcoming stuff that let's say the industry is working on. So there's a lot of people trying to use such sources to do nonlinear optics. So in the field of superconductor generation, but also in the field of parametric down conversion, things like that. There's also a lot of in-volume, let's say, imaging that you can do with the mid-infrared pulses. And the last two is about silicon photonics. So there's the new field of mid-infrared silicon photonics, in which you need light sources which are stable and that has, let's say, perfect beam quality that you can inject into such chips. And then with all of that, you can target spectroscopy applications. The second laser platform that is very popular is the Femtum Nano 2800 series. So this is the world first, let's say, high energy per pulse fiber laser emitting at 2.8 micron. So we can go up to 100 microjoule per pulse. And again, with the diffraction limited beam, which allow you to have like super high fluence on a very tight focal spot. We have pulse duration going from about 40 nanosecond to 200 nanosecond. And right now the platform is up to 30 kilohertz, up to 3 watts. We're working hard on, let's say, increasing these specs to have like higher power in the next generations. And just to show you, let's say, the power of this platform for microprocessing. One thing that is not well known, but is super important for microprocessing is that you need to have pulse-to-pulse stability, because when you don't have pulse-to-pulse stability, you have a lot of process variation, and it's not, it's super effective at the end. So in our case, you can see, because we have the gain medium directly in the mid-infrared, it's a super high pulse-to-pulse stability. And you can see here that, let's say, we're working on super high power, let's say 6-watt systems, and we have done long-term analysis, and let's say these lasers are very rugged and robust. What you can do now with such a laser platform, so I'll just mention, let's say, 3 types of applications. You can do micro bumps or texturings on the surface of polymers. So you can see here on the left side, we have induced micro lenses on polycarbonate. That is let's say, an advanced application. One that is, I think, of high interest is on the welding side of polymers. So many, let's say, polymers are easily weldable, but when you go into the transparent polymer and films, then certain set of polymers are very hard to weld. And one that is in particular very hard to weld is a PET on polycarbonate, in which we have succeeded to weld with our, let's say, laser platform. And we have done a bunch of different laser welding. Here is just 3 examples, but on the very popular polymer that everybody use on many industries. And for sure, if you increase, let's say, laser energy or, let's say, fluence, then you can go into the ablation of polymers. And what you can see on the right side is the ablation of epoxy on glass. It's super clean ablation where it's really interesting for many applications in the advanced, let's say, devices where epoxy is widely used. Another set of applications that Femtum is working on is on the selective laser processing. So basically, this goal is to do you try to modify or ablate or remove one material without affecting the second material. And that's very hard to do sometimes with conventional lasers. And it's pretty efficient to do this at 3 micron. Here's let's say 4 examples. So polymer on metal. So let's say wire stripping. There's also optical fiber stripping where you have two transparent materials and where 3 micron acts very well. There's also thin film processing. So here's an example on NTO on PT, but we have done a lot more than just this one. And please contact us about what we've done on thin film processing. And it really relates to touch screens or let's say solar cells patterning, the upcoming solar cells. And you have another example on golden glass. So it's a pretty, there's a lot of applications in the selective space that we are working on. So Femtum, we are a Canadian startup, and we are seeking quite high growth. Right now, we are based in Quebec, in Canada. I speak French, je parle français. We are 10 people full-time. We have 4 people part-time. We have access to world-class labs. So we are at ENO. It's the equivalent of a Fraunhofer in Germany, but in Canada, it's the biggest one, and there's only one. So it's a big center, and we have access to all the equipments. We are a spin-off from the CAOPL, so the at Laval University, which is a pretty renowned research group in the mid-infrared fiber laser technology. Currently, we have 4 distributors. So we have Soliton, which covers Germany, Austria, and Switzerland. We have Pulse Power for China and Hong Kong. We have Photonics Express for UK and Ireland, and we have Beams for Japan. And I guess today I've tried to convince you that we are making unique lasers and that we're the right guys for you when you're trying to tackle such applications. And we're very proud members of EPIC. And thank you again, all the team of EPIC for organizing this talk today. And we are an Optica member and Optonic a member. Optonic is the Quebec equivalent of EPIC. So today, my objective is for sure having new adapters on such, let's say, lasers. But we are also actively seeking solution partners because we are more a subsystem in a real machine. So we integrate a lot of components that goes together, and then we make the laser solution. But we also make, let's say, the beam delivery, the optical head at the end of the laser. We develop, let's say, laser processes. But at the end of the day, what we need is people that make the tool, let's say, the full machine. So we're looking for, let's say, such companies that can assemble the full machine for automated laser processing. And suppliers, and I'm very happy because already today I've found potential new suppliers on, let's say, particular stuff. But the 3 micron space is very, let's say, emerging. So there's a lot of room for development of new, let's say, optics. So in all the sense that I can talk, so we're looking always for lenses, filters, coatings, anything, isolators, like because right now the space is very emergent, and there's a lot of room for new, let's say, new optical devices. Thank you very much. You can reach out at info@femtum.com. We have a pretty nice website. We have a blog. Please read our blog. There's a lot of nice articles there. I'm Louis-Rafaël, Robichaud, the co-founder and CEO. Thank you very much for your time.
Thank you very much, Louis-Rafaël, and also for putting on the table all these requests and potential collaborations with your company. We have time for questions. I have one related the processing of this dissimilar material, let's say in plastic and metal. Do you have any experience now with this electromobility world? Because in some cases, in some connectors, there is a need to remove plastic coating on the copper cable inside for battery connectors, for example, in some other parts. I don't know if it's a kind of topic that you have in mind or you have approached it.
It's a very good application, I guess. I think to me, the best laser to do this right now would be a CO2 laser because, you know, what we really perform very well at Femtum, it's on the macro side. So when, you know, we are doing very small stuff, small features on small parts, when you're going to the very large, you know, high volumes, then let's say the higher power CO2 laser is the dominant player for such application. So I think the product market fit is on the CO2 laser for this one.
Okay. And any idea in mind to extend the wavelength range or move to other wavelengths, or do you, for the moment, keep in this region and explore all the possibilities?
Yeah, well, it's a super active research field right now on, let's say, how to increase the wavelength. And what I can say is that we are not a research lab anymore, so we are not working on making such new, but we are working with a lot of research lab on that. What we want to, you know, we are qualifying our lasers. Maturity is really important, the robustness and things like that. So, I mean, right now, for the short term and medium term, I don't see this really happening. In the long term, you know, if somebody comes with a very efficient fiber with a simple pumping scheme, you know, that can last long time for, you know, higher wavelengths, I'm all ears, but I don't think it's available right now.
Okay, good. I guess you have a lot of open fronts already, so a lot of things to do for the near future.
Yeah, sure.
Thank you very much, Louis-Rafaël. Really nice presentation. Thank you for being here today. And we move now to our last speaker. I think Ian is still alive over there. So I'm going to go with the presentation from Vortex Optical Coatings. Ian is going to present as Managing Director of Vortex, the air filters, and also his challenges. So Ian, the floor is yours. And also thank you for being a sponsor in the meeting today, that your support is really valuable.
Okay, thank you very much, and hello everyone. Before I get too much into the talk about filters, just a few facts about Vortex. We've been going since 2009, so we're 14 years old now, and where has that time gone? I sometimes wonder. We're based right in the middle of the UK. We're a successful small profitable company, and making optical filters between 1 and 5 microns, that is our bread and butter, to coin a phrase. And we've been members of EPIC for about 7 years now. So the space we work in then, which is between 1 and 5 microns, I mean, just a quick reminder of what we're involved in. So in any just about all the applications we're involved in usually involve a light source at one end and a detector at the other, and the filter is the piece in the middle, if you like, that sensitizes the system to the particular gas or liquid or whatever it is you're looking for. So for 1 to 5 microns in particular, many materials have got substantial absorptions in that region. These wavelengths and frequencies correspond to they correspond to the signatures of these materials, and it's worth bearing in mind as well that these signals are very big, 5, 10, sometimes 20 times as big as what can be seen in the visible. So we're trying to hit a big target here in terms of detection. Okay, so what type of materials can be detected or differentiated in the infrared? Few examples here. Some of them you'll be very familiar with. There's been a lot of mention of gases this afternoon, and certainly carbon dioxide and the hydrocarbons are the two top of the hit parade gases, certainly. Also in the food industry, users in that space are very interested in detecting fat content, proteins, moisture content as well. Of increasing importance in the last few years is the area of looking for biomarkers for disease. So we're talking here about point of care medical applications, and the type of thing we're talking about is maybe a breathalyzer which is sensitive to some of the components that are indicative of different medical conditions. And it's good because it can be an early indication that you know, there may be something wrong. And of course, the earlier that something like that is caught, there's a better chance of a successful outcome. Plastics have been mentioned a few times. A lot of plastic separation is done using particularly tightly specified infrared filters and allied with machine learning. It's also used a lot to check for quality in foods. So that, for instance, that 25-year-old malt whiskey, is it really what it says it is, or is it a fraudulent whiskey? And likewise with things like olive oil as well. You can pay a lot of money for olive oil, but is it really worth €50 a bottle, or is it has it had sunflower oil or something added to it to make it look more valuable than what it is? And then a particularly very important application actually is it's possible to measure how ripe crops are in a non-destructive way. So this applies right from the field that it's growing in all the way to the supermarket. So the aim of the project is to try and reduce the amount of waste in particularly supermarkets, and also improving the quality of the food that we eat. So in summary then, any material where there are differences in transmission or reflection, that material can be detected in the infrared. Okay, so what the filter actually does, well, very simply then, the filter hugs that area of difference, or it hugs the absorption feature. Specific example that I'm going to give you now is this one that we worked on a few years ago now, which was to differentiate between methane and ethane. This is a blown up scale, and I think everybody knows that the hydrocarbons are fairly closely bunched together. And in this particular instance here, you can see that the methane spectrum is in blue and the ethane one is in green. So they are very close together. But if you could make a filter a bit like the green line there, which is quite narrow, you could differentiate between the two gases, and that's exactly what we've done. The filter in the top right hand of the screen there, that was a filter that we made that was successful in that particular application. So some of the things that we have put in our direction now by customers, so they're asking for filters that are very accurately positioned. Okay, they're also asking for filters that are increasingly narrow as well. They've got to be highly temperature stable, and cost, of course. Cost is an important factor in all of this as well. So taking the first one then, we normally talk about, for a narrowband filter, the center wavelength within that band, and it's now possible using the deposition technology to have filters that are plus or minus 0.15% of that center wavelength. 5-10 years ago, maybe 0.5%, maybe 1%, but now it's much better. Again, making filters increasingly narrow. People, this area is littered with jargon. They talk about the bandwidth of a filter, and that's normally expressed as a percentage of the center wavelength. And now it's possible to make filters that are 0.8% of the center wavelength, sometimes even less than that, 0.5%. We're actually targeting going below that as well. Temperature stability, that's important. In a lot of environments, there may be, in a year, a filter may see 100-degree variation in terms of its field of operation. So having that filter stable and staying in the same spot spectrally all year is very important. So temperature rise, which is normally expressed in nanometers per degree centigrade, to have that less than 0.1 per degree rise in temperature is fairly achievable now. Cost, normally of primary interest to a lot of people. Simple thing to say here is specify where it really needs to be tightly specified, but don't over specify outside that region. And the advice that I would give is no matter who you're working with, talk actively to your filter manufacturer. I mean, some of the simple things, like for instance, a filter which is square is 15 or 20% less than a filter that is round. So simple things like that, or a knowledge of simple things like that, can help reduce the cost as well. So to bring in the epic questions now, right at the end, what we can do for you. Well, hopefully I'll give you a few ideas there. We aim to work with you to make your detection dreams a reality. And the other side of the coin, what the community can do for us, we believe that infrared is becoming more attractive all the time. So I guess as a group of people, we've all got to share that belief as widely as we possibly can. A lot of people out there don't know about the possibilities of working in the infrared. One thing I would add, though, is certainly the lower cost of detectors. They're often the most expensive element in these instruments. And if they were to come down in price, that would certainly make more applications possible. You compare the cost of silicon detectors in the visible with, say, indium gallium arsenide in the near infrared, and there's quite a big price difference there. So that was really all I was going to say. It's a quick whistle-stop tour of what we do. That's my contact details there, and I'm happy to answer any questions. Thank you very much.
Thank you very much, Ian. Is there any question in the audience? Yeah, Oliver.
Hi, Ian.
Hi, Oliver. How are you?
I'm fine, and you?
Good, yes, very good.
What is the current or your standard about homogeneity across the wafer or the coating chamber these days?
Yeah, I mean, typically we coat a 4-inch wafer, and over a 4-inch wafer, you're seeing about. Bear in mind, this is for say the mid-infrared, somewhere around 3.5 microns. So over a 4-inch wafer, you're seeing about 20 nanometer variation. Now, I mentioned there 0.15%, which is a lot less than that. So there's normally a small area in the middle of the wafer that you have to discount, but the area outside that is a lot less than that. So yeah, you can get a high yield out of a 4-inch wafer.
Thank you.
Okay.
Any other question? I have a question regarding the characterization of your filters. Are you doing nowadays a characterization after the process? Do you have something in line during the fabrication?
Yeah, in some we've got lots of different machines here, and in some of them we do need to particularly where it's to achieve high transmission, you have to have optical monitoring within the machine itself, and a lot of it is automated deposition as well, because filters, especially infrared ones, tend to be maybe 5, 6, maybe 10, 12 hours long. So, fully automated and optical monitoring is very important in that respect.
Okay. Thank you.
You're welcome.
So I think there is no more question, and thank you also, Ian, for sharing the epic question with the audience. As I mentioned before, feel free to contact me if any question arise in the next hours and you want to be in contact with any of the speakers, so I can introduce you to them to discuss more in detail. And we are reaching 5 p.m. So I would like to finish the meeting today, saying thank you again to our sponsors, Actor Advanced Coatings, Photonics, and Vortex, because the support is really valuable for us to organize all these activities. And again, encouraging you to visit our website so you can check all the events in the next weeks and months. Most of the 2024 in-person events are already there. So we encourage you also to check and register as soon as possible. So it helps us also to have an idea of how to organize, how big the audience is going to be. So if possible, you can do it as soon as possible. So thank you again. And with this, I will finish the meeting today. Thank you, everybody, for being here. I hope it was interesting. I saw several good questions. So again, thank you and have a nice afternoon and morning for you, Louis-Rafaël.
Thank you very much.
Thank you very much.
Bye, all of you.
Bye.